Okay, so we are on number 1. You can just put it right there. Thank you. That's great. All right, so number 1, we'll go to Katrina. Could you read number 1? Okay, thank you. We'll go to Sam for number 2. Okay, so here's here's an example of something called a quadratic equation. What about this equation makes it so we call it a quadratic? It's to the power of 2. You see that x squared, you are looking at a quadratic equation. Like on the quiz and in practice last time, I gave you guys some equations that kind of looked like quadratic. Well, they were quadratic equations. For example, this is one of the ones you guys worked on in your group activity last time. And yes, it is a quadratic equation, but it was special in that you could get the z squared by itself. You added the 32, you divided by the 2, and then you just had a z squared equals. And then you could take that square root. That only works if it's a very special kind of quadratic. And so the goal of today is to take a look at and kind of remind ourselves of how we solve them when they're not special, like this 5x squared minus 40x plus 11. Okay, you guys saw in 106 some techniques for solving quadratic equations. If you are very, very lucky, then the quadratic equation in question can factor. And I'm just going to make something up. I'm not saying that this is right, but for example, 5x and x gives you the 5. To get an 11, maybe like an 11 and a 1, and maybe a couple of minus signs, something like that. Does that look familiar? I'm not saying that's the correct way to factor. I'm just asking if it looks familiar, like you've solved quadratic equations by factoring before. So if it factors, then that's the best way to go about solving it. I'll give you some practice later today where you do some by factoring. We're not going to talk about really how to factor. This is like one of those prerequisite things. But after class or in the studio, certainly you can get help, refresh your memory on how to do that. But today we'll talk about this idea of completing the square. So let me just kind of put a line through so nobody looks at this later on and thinks that that's the way to factor. I don't think that that's right. But this idea of completing the square, let's give it a shot. So we're going to solve this equation, and we're going to follow these steps right here. So here's the completing the square procedure for ax squared plus bx plus c equals 0. That's just like a general way to write quadratic equation. So first thing to do is divide all the terms by a. A is apparently the number in front of the x squared. How much is a in my example? Is 5. So this is a, which is 5. So what we're supposed to do is divide every single term by 5. Fair enough. So the first thing becomes just x squared. The next thing used to be 40. Now it becomes 8. And then it gets messy, plus 11/5. Just be comfortable typing or leaving that as it is. Don't worry about decimals, just leave it as 11/5. So we divide everything by 5. And then we move to part B. It says move the constant term to the right-hand side. So the constant term is the one without any x's in it. The constant, the number. The other things have x's. They vary. So let's move that to the right-hand side. So I guess we go x squared minus 8x equals, what does that become when we move it over? Negative 11/5. That's steps A and B. Any questions so far? Okay, step C. Take half of the coefficient of x and square that number. So the coefficient of x is what? Is that negative 8. That is the coefficient of x, okay? It's a number touching the x. So in our case, we're supposed to take half of it and square it. So if I take half of negative 8, what do I get? We get negative 4. That's the half part. And then we still have to square it. Negative 4 whole number squared is 16. It's a very funny thing that I'm telling you to do. Just this random kind of procedure. Take half of the number and square it. Turns out something good happens when you do this random sounding thing. So half of the number was -4, square it, became 16. Part D. Add the magical number you just found to both sides of the equation. So we are going to add what number to both sides? 16. Now it should not at all be clear why we're doing this, but at the very least, is it legal to add 16 to both sides? Yeah, as long as you do the same thing to the left and the right, it's legal, even though it might not appear to be going anywhere. Okay, so here's where something good happens. It turns out that the left-hand side factors. Remember how it's set up here in blue? Maybe you could factor something. Well, I don't think we could have factored the, well, maybe we could have factored the first guy, but we can factor this thing on the left-hand side. So let's see if we can get that with 2 parentheses. And let's see if we can kind of remember from back in 106, if you're going to build an x squared, what needs to go first? All right, they both have to be x. Trying to build a positive 16, there are a few ways to multiply things and get positive 16. What are they? Positive 4 and, okay, so it could be +4 and +4. Those are two numbers that multiply to 16. Any other two numbers that multiply to 16? -4 and -4. Other possibilities to multiply to 16? 8 and 2, or -8 and -2. There's one more possibility. 16 and 1, and then -16, -1. Do you guys know which of those 6 possibilities is the one that we want? How come it's the -4, Sarah? Sarah is looking at this kind of middle. Remember, we kind of found this weird thing, that -4, and all right, it's a little bit weird. Maybe it's a coincidence, but it turns out that that -4 is the right thing to put in both places. If you didn't have that magical number in front of you, we're looking for two numbers that multiply to 16 and add up to -8. And of all the possibilities we listed, -4 is the winner. Okay, and then we'll just copy the right-hand side here. So this equals 16 minus 11/5. I don't know what that is. Is that 69/5? I'm going to do some fraction stuff and just merge those together. Okay, the left-hand side, I'm going to rewrite because it happens it was two copies of the same thing. So it's really x minus 4 squared. Yes? And we're actually almost done solving this one. But before we finish, I just want to pause and say that in part E here, we didn't read it, but it's a little shortcut. It says factor as x plus b over 2a squared. Okay, there's a lot of symbols happening in there. But that b, let's see, so how much was b? A was 5. How much was b? B is -40, yeah. You can kind of grab all these letters here in the beginning. So this guy is b is -40. And according to this formula, it says you take b and you divide it by twice a. How much is twice a? It's 10. We take -40 and divide it by 10, we get -4. The same magical -4 Sarah pointed to, which ended up going in these parentheses. And it always works. This always works. No matter what a, b, and c are, if you add the right number, 16 in this case, to both sides, you will get a perfect square, and it will always be x plus b over 2a. Always. I'm not a fan of memorizing this thing. I'm hoping that you guys can factor this x squared minus 8x plus 16. But if you can't, there is a formula that always works. And then finally, how do we solve it? It feels like we haven't made any progress. I mean, it had x squared before. Now we just have a square on the outside. Thank you, Michael. But the progress is that you guys are able to solve equations like this because there's a real nice thing you can do to both sides to get rid of the squared, is to take the square root of both sides. And that's what the last step here is. Solve for x by first taking the square root of both sides. Don't forget what? Plus or minus. So I'm going to copy that equation, and then I'm going to put in my square roots. Square root both sides. The left-hand side becomes the x minus 4. Right-hand side, square root of 69/5. That's not a very nice number. Don't forget the plus or minus. And then finally, the goal was to solve for x. So what's the last thing I need to do to solve for x? I add the 4 to both sides. So x is 4 plus or minus square root 69/5. So what have we done? Well, we've solved an equation. The goal from the very beginning, and it's easy to forget because we've got so many steps in this problem, the goal was to solve this equation with the 5x squared. That is, find the values of x that make that equation true when you plug x equals back in. And it turns out that the numbers weren't very nice. 4 plus the square root of 69/5 and 4 minus the square root of 69/5. If you really like decimals, type it into your calculator and you'll see them in decimal form. And it turns out that those two numbers down there are the ones that will work when you plug them in for the x's in this equation. Okay, questions on, well, probably there are questions, but any questions at this moment, I'll give you time to practice again, but that's the process called completing the square. Okay, let's go to the next page. And we'll take a look at number 3, Andy. Okay, so there's the formula. Raise your hand if you've seen this formula before. Wonderful. Looks like just about everybody. Do you need to memorize this formula? I don't know, some of you probably already have. On every quiz and test, you're going to be able to write formulas and stuff on an index card or a piece of paper. So no, I'm not here to say you need to memorize this combination of symbols. The more familiar you are with it, the easier it will be to use, but you could write it on your reference card for next quiz. Here's this last part here. It says this equation can be proven by completing the square, and it says see me outside of class if you want to see it. You could take this equation with the 5x squared in it and solve it using that fancy formula. And I think it's something you guys all did when you took Math 106 or wherever you were before this class. And what will you get? Well, you'll get exactly this 4 plus or minus square root of 69/5. You'll get the same answer. It'll be in a slightly different form, but it'll be the exact same number. Like I said here, it's the most useful of the 3 methods. There's factoring. That's the easiest if it works, but usually it doesn't work. There's completing the square. That's what we just did. And then there's this quadratic formula. This is by far the most useful. And in fact, completing the square, some might argue, is not useful because any problem that you give me, I'm not going to complete the square voluntarily. I'm going to use this thing instead. So then you might ask, well, why do we do it? Well, part of it is that this formula was only figured out, can only be like kind of proven by using the technique that we just saw on the previous page. So like completing the square is useful because you could use it once to prove this really useful formula, and then you never complete the square again. There are a couple of moments where completing the square comes up in like a pre-calc class or a calc 2. It's really kind of like here and there and not very often. But this quadratic formula, that's something you're going to want to be able to use quite fluidly. I don't believe that I will ever ask you on a quiz or a test to complete the square. I don't think I'll ever force you to do that. Some of you might choose to do that if you're gluttons for punishment. I don't know why anybody would choose, but I don't think I'll ever go out of my way to make you use completing the square. But I did want to have you see it just the once. And let's go to number 4, and we're up to Sarah. Okay, so for example, in this last thing here, this square root of 69/5, do you think that's a nice number or not such a nice number? That is not a nice number. If you type it onto the calculator, you'll get some decimal that goes all the way to the end of the calculator screen. It would go further if your screen was bigger, okay? Square root of 69/5 is not a nice number. In math, we call it irrational. Irrational is the math way to say not a nice number. And in this case, how many answers did we get? How many values of x are there? There are two. There's 4 plus, the not nice number, and then there's 4 minus, the not nice number. So we had two not nice numbers, two irrational numbers. Suppose for 1 second, instead of 69/5, this was the number 9. No fraction, just 9. How much is the square root of 9? 3. And so you get 4 plus 3 and 4 minus 3. How many answers? 2. Nice or not nice? Those are quite nice. So that would be a different possibility. If it happens that the number you get under the radical sign is a perfect square, like 9, then you get 2 nice numbers, as opposed to 2 not nice numbers. 2 rational numbers is what that would be. Suppose for a second that instead of 69/5 you had the number 0. What is the square root of 0? 0. It is 0. So you could have 4 plus 0 and 4 minus 0. How many different numbers is that? That is one number. Because 4 plus 0 and 4 minus 0, they're both 4. So it is possible that you get a single number. Will it, in this case it was 4. Will it always be a nice number? Yep. So the only place the not nice number comes in is when you have to take the square root, right? So if that's a 0, then the square root part disappears and you just get the 4. And in general, if this part right here is 0, then all you get is this piece. It could be a fraction, but it's still a nice number. There's no square roots anymore. So it's possible to get one single number, which happens to be nice. Rational is our word for nice. And then finally, what if instead of this 69/5, it was -5? What would you say when I asked you to take the square root of -5? Not real. We've seen already so far we can't take the square roots of negatives, at least not until we introduce these things called imaginary numbers, which we'll see, but at the moment we don't have it. So the last possibility that Sarah read to us, you could have two non-real numbers that involve taking the square root of a negative. Okay, so the place to go to decide what kind of answers you're going to get is exactly in here. You guys see that when we played this game, I just kept changing the number that was under the radical sign. So that's the only place that matters in terms of what kind of answers we're going to get. And so because it matters, we give it a name. We'll come down here to number 5, Taylor. Okay, so the discriminant is that thing that I've circled up above. B squared minus 4AC. That is the discriminant. And so we're not going to read number 6 together, but we're going to use it as we do number 7 together. We'll go to the other Taylor. Okay, so let's take a look at part A. X squared minus 2x plus 4 equals 0. The goal here is not to solve the equation. You don't need to use the full-on quadratic formula. The goal is just to think about the nature, what kinds of solutions you're going to get. So we need to figure out what A and B and C are. And remember, those are just the coefficients of the x squared and the x and the constant in that order. So how much is A? It's 1. Somebody else, how much is B? -2. And somebody else, C? It's 4. Are there any questions on identifying A, B, and C? Because we can't do anything until we have A, B, and C. Okay, and so then once we've got A, B, and C, then we're going to find what our discriminant is equal to. The discriminant is that formula up at the top. B squared minus 4AC. How much is B squared? -2 squared is +4. Make sure you make it a +4. Then subtract 4 times A times C. 4 times 1 times 4. So what do we get here? 4 minus 16, negative 12. So what do we do with that information? Well, that would have been this thing that's circled underneath the square root. So for this example, if I wanted to use the whole quadratic formula, I would need to take the square root of negative 12. And what do you think about the square root of negative 12? It's not real. So the solutions to the equation here in part A, not real. And so that's this sentence that we didn't read to each other, but it says if d is less than 0, d was negative 12, then the solutions are two imaginary numbers. So since d is less than 0, two imaginary or not real imaginary numbers. Okay, and we're going to play the same game for part B. What's the one little twist before you do this discriminant business? How come? That's right. We've got to get standard form. And standard form means 0, not negative 25. That formula up above doesn't work unless it's 0. So let's add the 25 to both sides. X squared plus 10x plus 25 is 0. And then we're going to pick off our A and B and C. How much is A? 1. B is 10. And C is 25. Positive 25. If you left it as negative 25, you'd get a different answer. You get a wrong answer. Can you guys go ahead and figure out what the discriminant is with that A, B, and C? It's the same formula, B squared minus 4AC with those numbers. See if you can find that value. Okay, 1 vote for 0. Anybody else? Okay, 0 is good. And so that 0 is exactly what would have been under the radical, circled in purple. So if I asked you to take the square root of 0, what would you get? You get 0. So instead of having a plus or minus, which is normally like two different things, in both cases you're either adding 0 or subtracting 0, but you get the same answer regardless. So how many answers is that really? It's really just one. And is it a nice number or a not nice number? Only not nice numbers you come up with are the ones where you have to take the square root of something bad, like 12. You took the square root of 0, that was good. That was a nice number. So this would be 1 nice number. And the case that we're interested in here is part C. It says if d equals 0, that's what we got, then the solutions are a single rational number. So we're just going to write that down below. Since d equals 0, so we did have to change it. Yeah, we did have to change it. Yeah, that's an important step, though, is adding that 25. Yeah. Okay, questions on that? Okay, so you guys have 35 minutes, which is quite a long time, but there's a lot I'm going to ask you to do, and it follows here. It's all these solving equations, lots of quadratic equations. You're going to try to solve by factoring. You're going to try to solve by completing the square. You're going to try to solve by using the quadratic formula. What kind of answers should you get when you do it 3 different ways? Exactly the same. Okay, so lots of practice. Work with each other. If the whole group is stuck on something, that's when you raise the flag and I'll come around.